Welcome back to Math with Patrick. It's May 5th, and we're solving problem number 125 from this Daily Epsilon calendar. And this problem actually reminds me a lot of the problem we had 2 days ago, where we had a lot of powers of 2, and then we had some exponents with x in it. And my strategy 2 days ago was to just rewrite the problem and then try to express as many things as I could as a power of 2. And by doing so, I eventually found an answer. So that's what I'm doing here. Basically, every time I see some number that's a power of 2, I am just rewriting it as such. So like this 2 cubed is this 8 right here. And so if I add 32, which I'll express as 2 to the power of 5, all I've done is just rewrite the problem with a lot of 2's. All right, my next step is to simplify some of my exponents. So when you have stacked exponents like this, you can multiply them. I'll just keep this 2 to the power of x the same. So it looks like I have this stacked exponent idea as well. So I'll multiply the 2 and the x plus 2, so it kind of looks like that. And then I'm also going to lump in this extra 2 here. So all of this right here is just a whole bunch of 2's multiplied to each other. And then I have one more. And so I can express that by just ticking up my exponent by 1. So that's my exponent there. And then I'm going to add 2 to the power of 5. I still have no clue how to solve this, so I'm just going to keep trying. What I did 2 days ago is I factored stuff. I tried finding the greatest common factor out of both of these expressions, and then maybe that's going to help. So if I factor out 2 to the power of x, I'll be left with just a 1 right here. And then I need to think 2 to the power of x times something. When I distribute it, I'll get something here. And this should be equal 2 to the power of 3x. And I don't think 2 to the power of 2x works, because in this instance, I would add these exponents here and here, which, wait, that'd actually be fine, right? That would get me to 3x. Okay, never mind then. So I think I can put a 2 to the power of 2x right here. And then I should get 2 to the power of 3x once I distribute these. So moving forward, I'll see what I can do when I factor the right side. Looks like they both have a 2 to the power of 5 in common. And then so I'm also going to get this 1 in this spot, and then a 2 to the power of 2x over here. And this is actually really convenient. I have repeated factors on both sides, right? This factor right here repeats with this one right here. And so I could just basically cancel them out. I could divide both sides by the same factor, 2 to the power of 2x plus 1, 2 to the power of 2x plus 1. I am just left with 2 to the x equals 2 to the 5. And then we can compare exponents here. Clearly, x has to be equal to 5 for today. And just to double check, whenever you're doing algebra stuff and you divide both sides by a whole expression, it's really important that that number isn't 0, because dividing by 0 is not good. So just to double check, I know that 2 to the power of anything has to be positive. It's always greater than 0. And adding the 1 is just even more security that I'm dividing by a positive number here. I'm never going to be dividing by anything negative, actually, no matter what the value of x is. But importantly, I'm not dividing by the value of 0. So this algebra step is valid. I can divide both sides by that factor. And then I'm just left with a pretty easy equation here. We can compare the exponents x and 5, which shows that x is 5 for today. All right, cool. Yeah, I don't really know what this number is, to be honest. I guess that's a 32 over here, and this is going to be an even bigger number. But once we plug in that 5 back in for all of our values of x, we're going to get the same number on both sides. So it doesn't really matter what that number is. I'm certain today that x is 5, and we're all done. See ya.